Uh, Hi guys. I these two questions are from uh, these two questions are from ISI M.Math 2024, right? So first, let us do like the second question first. So this is a pretty easy question, and by the way, I got a drawing pad thanks to my friend. So yeah, so this is a pretty easy question. So so basically, we are given a wait a minute. So we are given a summation k equals 1 to infinity 1 by k limit n tends to infinity 1 by n to the power k plus 1. And yeah, I mean, so summation m equals 1 to n m to the power k, right? So now to do this, basically, uh, basically we just take we just take 1 by n to the power 1 by n to the power k inside. So yeah, this is actually pretty easy. So I'll just do k equals 1 to infinity and the same thing, and we do this uh, 1 by n and everything 1 by n to the, so basically m by n to the power k. So then now this is nothing but the limit as an integral sum, sorry, integral as a limit sum, sorry. So yeah, so basically this will be summation k equals 1 to infinity 1 by k, and this whole thing will be integral 0 to 1 x to the power k dx, which is nothing but summation k equals 1 to infinity 1 by k is 1 by k plus 1. And now this is a pretty famous series. This is a telescoping series. So this thing will be right. This thing will be like summation k plus 1 minus of k by k into k plus 1. Yeah, and also of course it's 1 to infinity. I will not write this again, but yeah, so summation basically we will get 1 by k minus 1 by k plus 1, and yeah, this is basically 1 minus 1 by 2 plus 1 by 2 minus 1 by 3 and so on. So and so on and so forth. So yeah, so the answer will be 1. So so the answer to this question, I think, will be 1. Now let us move on to a an interesting question. So this is a pretty cool question, nice question. So let's see. It is given that like basically they are saying that uh, summation n equals 1 to infinity. Basically n is convergent. So basically this converges. So basically this converges. So which of the following statements must be correct, right? So this is the question. Now the first statement is false. Okay, the first statement is definitely false because we know we can take this counter example. Say let's say, yeah, it's a pretty common counter example. Let's say n is minus 1 to the power n 1 by n. So by Leibniz test, this is summation n is convergent. Summation n converges. Summation n is converges. Yeah, because 1 by n is monotonically decreasing and it tends to 0. So so basically, so yeah, so this is not necessary that, but yeah, but summation mod, that is not convergent, right? But that is not convergent. So but summation, this is not convergent. This is pretty famous, not convergent. So now for option two, I mean option three can also be easily discarded because yeah, option three can also be easily discarded because it says that like both this and this must converge. So, but say we take, so basically they are saying that mod an by root n must converge, right? Converges. I mean, this converges. But this is not necessarily true, right? So because say we take, right, we can take n to be minus 1 to the power n, 1 by root n. Again, by Leibniz test, we see that summation basically summation an is convergent, converges, but okay, this okay. So, but summation mod of n by root over n equals, yeah, summation 1 by n. Sorry, summation 1 by n, which diverges, which diverges. So, yeah, so this is option 3 is also false. Option 3 is false. Okay, now for option 2, right? Um, basically, like for option 2, basically given that summation n by n and summation uh, acha, mod an by n square both converges. I mean, this is pretty obvious because this will converge because say an tends to 0, right? So basically mod an will also tends to 0, right? Right. Because yeah, because like I mean we can just take an less than epsilon for all n greater than equals to sum n and given any epsilon. So I mean yeah, so basically for mod n it's the same. So mod n also less than epsilon. Yeah, so basically n this will also tends to 0. Now 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 let me draw the real line 0 1. So mod of an tends to 0, right? So mod of an, so it's positive, so it approaches 0 from this side, right? So like after finite terms, like after finite terms, like uh, let's say after like let's say n terms, capital N terms, mod n will be less than 1. It has to be less than 1 because it tends to 0, right? Because we can take any neighborhood and the infinite number of terms basically, so infinite number of terms will be in that epsilon neighborhood, right? So after for certain finite terms, mod of an is less than 1, we can choose any epsilon and corresponding we get an capital N. So yeah, the usual stuff. So yeah, so basically after finite terms, mod n is less than 1. Now we can actually use the comparison test here because summation mod of n by n square uh, will be less than summation 1 by n square. Like we are not considering the finite terms, right? So yeah, like after finite terms, mod n will be less than 1 and so we can have this. So now this thing converges. This thing converges like summation 1. We know that summation, sorry, 1 by n to the power p. Sorry, my handwriting is so bad. 1 by n to the power p. This converges for p greater than 1. So it's a p series basically. So yeah, so this is true, right? So one part is true that summation mod n by n square converges. Now what about summation n by n? And so what about summation n by n? I mean one like I mean how to do this? Like I mean like my intuition is like it will converge, right? But to prove this, basically like what we can do is we can either use Abel's, I mean we can use Dirichlet test or Abel's test. So we have to see like which one applies here. Like the thing is we know that summation this converges, right? And because it's given, so it's given that this converges. And now we know that 1 by n, this is monotonically decreasing, and this is bounded by 1, and this is bounded by 1. Okay, so yeah, because of course this is 1, 1 by 2, and so on. 1 by 2 and so on. So this is bounded by 1. So we can use Abel's test. So using Abel's test, we get that summation n by n converges. So our option 2 is correct. our option. I mean, we don't have to actually do option two because I mean we can discard four as well pretty quickly. I think yeah, we can also discard four as well pretty quickly because I mean it is not necessary. Like we can actually see that it is not necessary that like mm, that yeah that summation mod n by n must converge. This is not necessary. I mean we can use that thing, right? That say again we use the same thing minus we take help of our display test minus 1 to the power n 1 by log n. So this basically same thing. So yeah, so 1 by log n is monotonic. I mean log n is monotonically increasing. So graph of log n will be like this. So yeah, but 1 by log n is monotonically decreasing and it tends to 0. Right. So this by Abel's test. So yeah, so summation an is convergent. An converges. Right. I mean less than infinity. Now what about mod n by n? So summation mod n by n, which is equals to uh, I mean this will be equal to summation 1 by n log n, and everyone knows that this does not converge by Cauchy condensation test, right? So yeah, I mean hmm, by Cauchy condensation test this does not converge, so we are done. So option 4 is also false, so only option 2 is correct. I mean in exam we can quickly discard option 1, 3 and 4. Yeah, so this is it for this. So yeah, this question was pretty easy, and this was also easy, but yeah, it requires a bit of work. But I mean, we can quickly eliminate this using counter examples. So yeah.